How's it going, Dr. Padilla? My name is Devin McCall, and I'll be presenting to you this program that I made. What it does is it solves for the focal length of a lens given initial values that we find. So this is the main function, not too much is going on over here. Let me show you behind the scenes. Over here, we'll see that I developed a class focal length, default by private, and these are all the functions that I'm going to be using. Here are all my private variables, and let me show these from over here in my CPP file. So over here, let's start from the top. Let's go down. So over here, this is gonna ask, or first it's gonna output my welcome message, which is right here. Next, it's gonna ask, hey, is this a diverging lens? Yes or no. If it is true, then it's gonna make that a true statement. Otherwise, it's gonna ask if it's a converging lens. Yes or no. If you say yes, then it's gonna make that a true statement. Otherwise, if none are true, it's going to throw a runtime error. It's going to stop the code immediately, say, hey, you're doing something wrong. Next, we start asking for initial values, seeing what we have. So ask for the distance of the object. I ask for the distance of the object, distance of the image, for the magnification, for the height of the object, height of the image, everything here. And let me show you those functions. So whenever you ask, it'll run these little blocks of code, which then take the input and set the value there. So next thing we're gonna look at here is gonna be the actual calculation functions, which are the hardest ones that I had to do. But let's check them out. So first, it's gonna calculate magnification. This one it doesn't just do magnification; it actually does a lot of stuff. So here, if you don't have the magnification, it's going to say, oh, if I have the object height and I have the image height, solve the magnification. Now it is true that I have it. Otherwise, if I have the distance of the object and I have the distance of the image, solve for the magnification. And it's true that I have it. But let's say I already do have it, or I just solved for it. I want to solve for some other missing variables. Over here, you can see that if I have the distance of the object, just not the image, you can solve it using the magnification, just by balancing the equation. Over here, you'll see the same thing, but for the distance of the image and not having distance to the object. Here, you'll see it for object height, no image height, and here you'll see it for image height, no object height. Now, this is one final check to see if there's something wrong with your logic. So, if the magnification calculated by your image and your object are not equal to the magnification solved for by the other, it's actually going to throw a runtime error and say, hey, this isn't right. And that's also considering you have every single variable solved for. That's the only way to really know if it was wrong. If you didn't have your height of either, you can still solve for the focal length, but you won't know if it's wrong data. Down here, these are just getters. I never use them in the code, but they're good for troubleshooting later on. If you'd like to call this from the main functions, it'll actually output the stuff within the object, the values that we solve for. So now that I've showed you the inner workings of the code, let's go ahead and see how it all works once I actually run this guy. Close these up. All right, let's run it. See how it goes. I actually have been running it a little bit, so it might be a little bit ugly. Yeah, actually, let me delete this so it looks a little bit prettier. Cool. Let's run this one more time. Cool. Welcome to my focal length calculator. I hope this will be useful for optometrists attempting to determine a required focal length for a lens. Please input the values that you have. I'll calculate the missing ones. Perfect. So, diverging or converging. Let's say it's a converging lens. Do I have the distance to the object? Let's say I don't. Let's say I have the distance to the image. Yes, I do. Let's say it's 30 centimeters. Okay. I do have the magnification. This one's going to be 6. I don't have anything else. Boom. Solves the magnification. Solves for the focal length. Let's try something else. Try something where I'm actually going to have to solve for stuff. So let's run it one more time. Let's say it's diverging this time. I do have the distance to the object. This one's going to be 5. And let's say I don't have the distance of the image. I don't have the magnification. I have the height of the object. This one's going to be, let's say it's 8. And let's say I have the height of the image as well. This one is going to be 16. Something easy. So you see here, it did solve for the magnification, and it also solved for the focal length. Now, let's try one where the values don't match up, where my magnifications are not equal. So let's say it's converging this time. Let's say I do have the distance of the object. That one is going to be 4. I do have the distance of the image. That one's going to be 2. And I don't have the magnification. It's going to solve it. Okay, let's say I do have the height of the object. That one's going to be 6. And I have the height of the image. And for this sake, let's just say it's 3. Let's make it wrong. Actually, no, that's correct. Let's say 2. You'll see that over here, an error is actually thrown saying that it's inconsistent data and that we actually do need to correct something within our code. I'll be showing this to you later on this week as well. Hope you enjoyed the code. Let me know if you have any questions or anything you'd like to check out. I hope you have a great rest of your day.